Hi, welcome to another session on data wrangling. And in this video tutorial, we'll be looking at clean operations in the data wrangling wizard. The clean operation is a crucial step in preparing data aimed at improving the quality and trustworthiness of the data. It helps fix any mistakes, inconsistencies, or gaps in the dataset. The goal is to make sure the dataset is precise, complete, and ready for analysis or further use. You need to open the clean operations study file from the list, and you see that again we have PC and EX datasets have performed basic transformations. We will click on the PC derived dataset over here and click edit. So I have selected important columns that would be helpful for us to understand the clean operations. If you click on the drop down under clean operations over here, you see there are two things, the remove duplicates and there is impute. Let's look at it one by one. First thing, remove duplicates. This operation, um, so in the data set generally we'll have duplicated records, and this can lead to inaccuracies and affect the outcome of the data analysis, and thus underscoring the importance of having unique entries in datasets. The remove duplicates feature within the cleaning tools helps in locating and deleting redundant entries to ensure each record in the dataset is distinct. So what we can do here is using the PC dataset, like we just open, we can use the remove duplicates operation, and in this select subject ID, and any duplicate records in the subject ID column are deleted, leaving only the first instance of each subject in the dataset. So here, before I click somewhere else in the screen, you see that I have selected subject ID over here, and the subject ID uh, one has multiple entries over here. Let's say more than 20 rows, correct? And that is because we have different time points. So once I perform this, you see that only the first instance for each subject uh, will be uh, will be saved and others will be excluded, and um, the result data set is created. So let me click outside of this function that I just performed, and you see that only one entry of subject ID is there, and first instance, that is time where it has 0 hour post dose is just retained. And this is the unique records, leaving out all the duplicated records with respect to subject ID. So this, um, uh, as I said, um, it keeps only the earliest records of each um, uh, ID, and I can click this drop down where I selected subject ID and also chose visit. Maybe I just chose subject ID first. Now let's choose visit also. So what does this do is it retains only the first occurrence of each unique visit. So effectively keeping the earliest record for each type of visit that we have in hand. So here for each subject ID and visit. So here in the PC dataset, if you look closely before doing the remove duplicates option, there were 4 different periods, period 1, 2, 3, 4, and samples were collected on day one of these periods, and uh, for a particular ID. And you see when I did this remove duplicates, combining both subject ID and visit, um, the unique records in visit were retained for each subject, and the concentration or the time point at that particular, the earliest instance are shown. And one more thing, to ensure the first occurrence of each visit is kept across all subjects, remove duplicates needs to be applied to both subject ID and visit column like we have done here. And this functionality aids in maintaining a clean and reliable dataset by removing extra copies of the same records, which is vital for accurate analysis. The other operation that we see in the screen is impute. So let's look at what impute does in the data wrangling wizard. What we'll do is we'll just cancel this transformation, and we will go to the EX derived dataset and click edit. So the impute operation here, let me click on clean, and yeah, we have the impute operation over here. So generally, I mean, when we have datasets, missing values are common issue in these datasets and can negatively impact analysis if not properly addressed. So the impute missing values feature here in the data wrangling wizard offers a variety of tools to effectively manage and replace missing data with estimated or calculated values. There are different imputation methods that you can select. Example, interpolation, LOCF, NOCB, replacing values, or using a simple random sample, or maybe substituting these missing values. So let's look at these operations one by one. So what I've done here is I've performed a basic transformation, and here I've selected important columns and then created a replaced the ex dose column. So this was already there. What I've done is wherever ex sequence is equal to 2, I've kept that particular ex2's value as missing, and all others are as usual. So let's try to impute this missing value using the different methods that I just mentioned, using the impute operation in PumasCP. So in this EX dataset example, uh, what we'll first do is we'll group by the subject ID. So this is recommended before imputation. Let's click on group by and choose subject ID. And next, um, as I was saying, EX dose is missing at all sequence when the sequence is equal to 2 everywhere in the dataset. Whenever you see EX sequence is equal to 2, it is missing. So let's start imputing these. So once you perform group by, we will start imputing these missing values. We'll click on impute and select interpolation. So this interpolation function, what does it do is it calculates the missing values by averaging the adjacent data points over here. Um, so what I need to do is, so I need to impute the missing values in the EX column. So before choosing the type of imputation, let me, instead of choosing the subject ID, I will choose X2 as my column that I need to impute. So I'll choose the type of imputation as interpolation, and you observe that the missing values are now imputed with the value of 7.5 for each subject at ex sequence is equal to 2. So as I said, interpolation performs this imputation by averaging the adjacent data points. That is, here we had 5, 10, and 25, and using that is averaged and given us the value. And uh, we will look at the second option or a second method that we can use to impute the missing values. So let's again close this impute option. So we have the missing values now. Let's click on impute again, and instead of subject ID, choose dose, and in the type of imputation, choose LOCF or last observation carried forward method. So what does it do is it takes it reads the data and sees what is the last observation, and it carries that observation forward and imputes that. Again, a simple operation, and you all know how does LOC works. I won't um, get deep into that. Next operation is NOCB. So I click on this and choose next observation carried back. Um, Yeah, so here the value 10, dose 10 was the next observation after the missing value, and it has now imputed by doing the NOCB method. Same way, let's now do a different method. Um, After NOCB, we have, let's say, before I show the replace with value method, I'll show you a simple random sampling method. So this, what does this do is it randomly selects observed values to replace missing data. Here, in the first ID, you see that when X sequence is equal to 2, it has imputed 5. And in when for the subject ID 2, when X sequence equal to 2, it has imputed 10. So it randomly selects based on the observed values that we have in the X dose column. So this is simple random sampling. And the substitution, let me click on this. Yeah. So instead of simple random sampling, I'll choose substitute with a statistic. And here, um, so I can fill these missing values by selecting a suitable statistic as a substitute. So the summary statistic like minimum, maximum, mean, median, mode, anything of these can be chosen to substitute with the substitute the missing values. I can choose minimum for now to show you how does it look like. Yeah. So this is with substitute with statistic option or the method that you can use. I hope these clean operations will be useful for you. Thanks for watching.